Hello, my name is Jared, and today Jahi and I will be going over your seventh lecture, which is the Introduction to SQL and Spreadsheets. And so many of us have used Google Sheets or Microsoft Excel before, so this might be a review for some of you, but this will be helpful for the assignment that you have this week. And so first, we just have an overall introduction to Sheets. And so when you open a new spreadsheet, you're given all these this entirely blank canvas that may look like this with no layout or any values within these. And so as you can see here, each rectangle here is what we call a cell. And so when we group cells together, we're given these columns and these rows. And so the columns of a spreadsheet are what we have here in this table, each of the specific columns with the labels like name, weight, K count, and price. So everything within the name, everything below name would be considered a column. And so these are defined by letters that start with A. So name would be A, weight would be B, K count would be C, and price would be D. And then on the other hand, we also have rows, which is the horizontal group of values. So here we would have, and these are denoted by numbers that start at 1. So if we were to look at all the labels, this would be row 1, and if we would look at crawfish and all the values to the right of it, that would be row 2, and so on. And so if we wanted to index into a specific cell, such as crawfish, we use a cell address, which is a combination of the cell's column and the row. And so if we were to try to index into crawfish, we would go into the first column, which is column A, because it's in the name column, and we would go into row 2. And so this would give us the crawfish cell. And if we wanted to do the same thing for the value that says 84 kcal, we would go into the third column, which is C, and down to row 4 to get C4. Next, we have range and formulas. So range is what we call a group of cells, and it's defined from the very top left cell to the bottom right cell. So as you can see in the table, we have this highlighted range. And so the top left cell would be 241, which is where it starts, and it would end at 84, which is the bottom right cell. And so when we have a range, we denote it by having a column between the two cells. And so in the example, B3 is the top left and C4 is the bottom right. And going off of this, we also have calculations that can be performed in Google Sheets or Excel using formulas. And so this is essentially similar to what you would have in a calculator. So say we wanted to make a formula with B2, which is 123, and D2, which is 115. We could use different mathematical operators such as plus, subtract, multiply, divide, exponent, and PEMDAS. And so it's pretty simple. You just whenever we input a formula into a cell, we always start it with the equal sign. So say we wanted to add B2 plus D2, we would go into a cell and we would type in equals B2 plus D2, and that should give us our answer. And so in Google Sheets, it's very similar to how we would do a mathematical operation on paper. So if we were to use parentheses and have multiple different mathematical operators within a cell, they would follow the PEMDAS operations. Within Sheets, we also have percentages and comp operators. And so essentially a percentage is denoted by a number that is followed by the percent symbol. To calculate the percentage of a number, we multiply that number by a percentage. So say we wanted to multiply 123 times 71, which would give us 87.33. Or we wanted to do this for the same thing, we could reference the cell using B2 times 71%, which would be equal to 87.33. And over here, you can see we're using a mathematical operator. So if we use this function called sum and we pass in a range B1 to B4, it will take all the values within that range and add them up, and then we would multiply that by 109%, which is give us 870.91. This is very helpful. So for this example, specifically, say like you were with a friend, you'd be able to add up the total weight for like a crawfish boil and multiply it by 109 for tax, and this is how much you'd pay for it. And so we also have comparison operators, which can be used to check whether values are less than, greater than, or smaller than another value, and returns a Boolean. So in Excel, Boolean is just a binary value, right? It's either true or false. And so here you can see we have smaller slash greater than, smaller slash greater than or equal to or not equal to. And so the not equal to symbol, because we don't have the equal sign with the slash through it, we use the less than and greater than symbol together. So in these examples, you can see if we have 3 is greater than 4, we know that that is false, so it will return false. And the other one is true, so it will return true. Here we have data types, and so first we're going to be starting off with text and numbers. And so within each of these cells, each of these specific cells has a unique data type within it. And so the data type on the table on the left has text, number, and currency values. And so in the column A, we see that there's just plain text. It's just the name of the type of food. And so the default type is the text is the default type if no other type is recognized. And say we want to input a number, but we don't want it to be recognized as a number, we can input this parenthesis or quotation, single quotation that would make it read as a text rather than a number. And all text is by default aligned to the left. Within the weight and kcal columns, we see that we have numbers, so they will have the number type, and these are aligned to the right by default. And I've been talking about the alignment, and so when we reference the alignment of a cell, it's just essentially the text in the cell. So as you can see, left is left, middle is middle, and right is right. So within these, we have this new table now. So this table is just like a mock-up of our football season and our games as well as kickoff and admission. So say for like all the games, we have this admission price, and so within the admissions column, we would have a data type currency, and so values within this column would be denoted by the $sign. And so on the very left side of the table where there is the date, this is used to reference a period in time. And so when we're referencing dates or time in Excel Google Sheets, there's many different formats, but for this one specifically, I choose to use the year, month, day format. And so Sheet automatically attempts to interpret your data based on the symbol inside of it. But sometimes you don't want it is not recognized correctly. So in order to change this, as you can see in this picture, say we wanted a decimal instead of a whole number, we would go into number and we would choose the specific format that we would like. So next we have logic, and so similar to like our operators, we get a true or false from it, and so logical cells will always be, or will by default be aligned to the center of it. And when you enter true or false into a cell, it'll be recognized as a logical, and it will automatically capitalize these Boolean values into capital true or false. And so we can also use logicals with comparison operators. So for example, if we had true does not equal false, we would get true, and if we had true equals true, that would also be true. But if we had something like true equals false, we would get false. So in Sheets, something that is very, very handy is being able to copy your references. And so referencing becomes especially useful, so if we start copying the references around, and so when we copy formulas containing references to neighboring cells, the references will also shift along. So to copy a neighboring cell, you want to, as you can see in this demonstration, you want to select the cell and move your mouse to the lower right corner, and you'll see the plus sign along with this blue box, and you'll just drag it down. And so we can do this by column as well as also rows. And so say you wanted to make like this column of like 1 to like 100, but you didn't want to type all of them, you could type in 1, 2, 3 first, highlight it, and drag it all the way down to the 100th row, and it would automatically give you numbers from 1 to 100. And so in this example here, we see that in this cell right here that is highlighted in blue, we would have this equal to A2, which is equivalent to what is in this cell. So if we were to drag this down, we would be copying the references, and it would increment in a sense. So the next cell below that would be equal to B2, which would also copy the reference from this one. So now that we've gone over copying references, we will also go over absolute references. So the ones that we just went over, we call relative references because they change when we copy them to other locations. But there are also these things called absolute references that don't change one of its value when you copy it to another cell. So these are created by implementing a $sign. And so a reference, so when we implement the $sign, it essentially makes this absolute reference. So say we go back to the other example and we were to drag this down, instead of it copying to B2, if we had a $sign 1, we would also get this 9 number here. So because it is not incrementing, we will maintain the same reference throughout all the cells. And so a reference can be partially absolute, where only the column or the row is absolute. So if we had $sign A1, we'd be locking the column. And if we had a $sign 1, we'd be locking the row. And so this can be especially helpful. Say we had all this revenue, right? And say that Berkeley takes away 25% of their revenue for themselves. If we were to have another column that had the specific tax, we would be able to do something where we reference the revenue and we can multiply that times the specific cell. Say the cell was D1, we could do $sign D, $sign 1, and multiply that by each of these numbers. And if we were to drag that down, all these references would be multiplied by the absolute reference, which would be the 25% tax, and then we would get how much revenue they'd be left with. And so lastly, within Sheets and Google, or Microsoft Excel and Google Sheets, we have functions that can be used to create formulas that manipulate data and calculate strings and numbers. And so some examples are abs, which is just the absolute value. We have floor, that when dividing a number, we floor this value. Rounding, which just rounds a number. Sum, which adds all the values that are highlighted. Average, which averages all the letters or all the numbers. And we have concatenate, for example, which would add 2 strings together. And so there's so many functions in Google Sheets that are very helpful. And over here, I have a link to just the references of different functions in Google Sheets that you could look up and maybe just mess around with and find things that you see interesting and try them out. And so I think that covers it for our introductions to spreadsheets. And so a lot of this content you'll be practicing within your boot camp, your data camp assignment today. And so feel free to reference back to these slides or attend office hours if you have a little trouble completing the tasks. Hello, so today I'll be giving a spreadsheets demo. So today we'll be covering sorting values within cells, creating a chart, as well as going over conditional formatting. And so over here we have some demo data that I created. Say that this is like our Cal soccer team, and so we have the player names as well as their jersey number, and let's say this is the number of goals that they scored in the last 10 games. And so say that we have all this data, but we want to look at it in alphabetical order by name. And so Sheets in Excel has this sorting feature where if we highlight the cells that we would like to be sorted, we could double click on it or right click it and go to sort range. And say that we wanted to see it alphabetical order by name, we can click that we want to sort it by column B, which is here, and we want it to be alphabetical, so A to Z. And so if you click sort, we can see now that all the names are in alphabetical order, and we could also see that the number and goals associated with them also changed. And so in this case, if we wanted to just sort the names, we could just highlight the name cell. But because the number of the jersey and the goals is associated with the name, we need to highlight the entire range when sorting so that the entire row shift with the sorting feature. And so say now we wanted to sort these data by their jersey number. So we go back into the sort range feature and we go to the jersey number, which is column C. And say this time, instead of going from smallest to largest, so A to Z, which is also 1 to, let's say, infinity or largest number, say this time we want to go Z to A. So if we're sorting it from Z to A and we are sorting it by a numbers column, we should expect the greatest number to be on top and the smallest number to be on the bottom. So if you click sort, you can see that the highest jersey number 10 is on the top and the lowest jersey number is on the bottom. And say now we want to maybe increase our complexity when sorting. Say that first you want to sort by the highest number of goals that the players score, and then after that we want to sort by the names alphabetically. So we can see here that there is repetitiveness within the numbers of goals, and so if we were to just sort by goals, there'd be no condition to sort it after that. So let's see. If we were to sort by just the goals and the highest number of goals, Z to A, and sorry, let me change this to column D, we see here that we have all the highest number of goals on top and the lowest number of goals on the bottom. And then there is no second sorting feature, so it automatically sorted it by alphabetically. But let's say we wanted to do it from the last alphabetically from Z to A and by the goals. So we could go to sort range and say our first sorting feature would be by goals. And we want this to be from Z to A because we want the highest number of goals. But instead of having names be alphabetically after that, we want it to be reverse alphabetical order. So we could, after sorting it by D, we could sort it by the name column and go Z to A. And so this time, we see that we still have the highest number of goals on top. However, we see that the names switch, and now the last we have alphabetical in reverse order. And so, say now that we've learned about sorting, let's move into creating charts in Excel and Sheets. And so, say we wanted to see if there was a correlation between the jersey number and the number of goals that are scored. And so, when we're creating a chart, we want to highlight the total all of the data that we want represented within the chart. So after highlighting this, we can go to Insert, and then we can click on Chart. And so Google Sheets automatically created this column chart for me. However, because we want to look at sort of this correlation, we want to get a scatter plot. So in the chart editor feature, we can go to chart type and we can go down and click on scatter plot because that is what we would like to see. And we see now that we're given this scatter plot. And so say we wanted, or we can sort of see that there's not really a correlation between jersey number and goal score, but I think that is what we expected. And so if we can go into this customize feature and go into a lot of different things. So one of the options we can go to is series. And so within the series option, we're giving these additional features that we can add based on the data we pass into it. So we can have error bars, we can pass in data labels, or when we're looking to find trends, we can click on trend line and it'll automatically do linear regression for us and calculate it. And so we could also have the option of using labels such as showing the equation that was calculated as well as our square valued, and it'll show at the top of our table. And so these are a lot of additional features that come with creating charts within Excel and Sheets. So instead of manually having to calculate our regression and our square value, we can just plug it into here and it'll automatically create our table as well as calculate trend lines for us. And so say that we don't really like the style that our table shows up in. So in order to restyle this, we could just click on any feature we'd like to restyle, and within our chart editor, we can edit the alignment of it, the font that we'd like to use, the size of the font, and just mess around and change the color or anything that we'd like in order to make the chart more similar to our preference. And so this pretty much covers the chart feature. There's a lot of different charts that you can make, and you can just play around with it and see how your data changes with the different types of charts that you choose. And here now we have like a donut chart, and you're still able to see representation. And yeah, And so lastly, we're going to be covering conditional formatting. So conditional formatting is something that I really like when I have a lot of data to go over and I need to find which type of data kind of correspond with each other. And so say here, I'm just going to give an example and we can go, I'm not really sure what it is, so I usually just go to the help feature and type in conditional formatting. And so when we're in conditional formatting, it essentially allows you to apply these conditions that will self-format your table. So say, say we wanted to highlight, sorry, let me re-click on just the goals. And so say I wanted to conditionally format the number of the goals column, and say I wanted to only find goals that are within this that are greater than 3. So I want to just find the players that score the most amount of goals. And so, and I want, let's say I want this to be highlighted yellow because they're the best. So instead of having to manually go into sheets and highlight the parts that I want, we can automatically have this conditional formatting that will find all the cells that are associated with your condition and either change the fill color, the text color, or just change the styling of it. And this is really helpful when you have a really, really large table value and say that you want to just highlight all the numbers that are 5. Instead of having to manually find all the ones that are 5 and change the color, you could just conditionally format the entire range and change the color. Another thing I like to do within conditional formatting is say that we wanted to see the range of all the values within a column. And so let me just randomize the range. So this will just give us a random sorting of it. And so say that I have this extremely large data set and I want to see the number of goals, but I want to be able to associate higher numbers with the darker color and lower colors with the lighter color. So we could go back into conditional formatting and we can go into this color scale option. So this is the default setting, but say we wanted to have the highest number of goals as a dark color and lower scores with a light color. So this is what we call a color scale. And so within the color scale, we can apply our own conditions, but it highlights all the cells. It gives them like a gradient basis. So now that when I look at this, I can see all the players that are white are the players that are having trouble scoring, whereas all the darker colors are players that are great at scoring. And so instead of just seeing 5s highlighted, I can see this whole entire scale. And so conditional formatting is really cool, and I hope you guys found it interesting learning about sorting ranges, creating charts, and everything else. And I hope you guys have a great time doing the assignment.